So that is my LinkedIn and my Twitter. If you want to reach out or connect, I encourage you to do that. If you have questions you want to follow up with, you can either send them in through the Meetup or send them in through LinkedIn or my email. So what are we doing today? Let's just frame the challenge that we're working on here. So cybersecurity needs to go both fast and long. So if you think about cybersecurity breaches, and we're seeing just a huge increase in breaches over the past couple of months due to COVID-19. So, everyone started working from home, and this brought in a lot of vulnerabilities and a lot of backdoors. And whenever something like this happens, a lot of people try to exploit it with fraud. So there's just an unprecedented amount of traffic coming through, home computers and through ISPs that wasn't coming there before. And if you, almost reminding me that I'm not actually sharing anything.
Yeah, I was not sure if, yeah.
How about we actually share something? That would be a really good idea.
Oh, that's better.
All right, let's try that one more time. Let me show you there's my LinkedIn and my Twitter. I have a very distinct name, so I'm pretty easy to find there. So reach out. All right, next slide. Okay, so if we look at cybersecurity breaches, they can happen really quickly. So in a matter of minutes, right? So 82% of breaches happen within minutes. And the faster you can detect a breach, the faster you can remediate it and control the damage. So the longer a hacker sits in your network and starts exfiltrating stuff, the more stuff you're going to lose and the more damage is going to be done to your network. If you look at, there's been a study of state-sponsored attacks, the fastest state-sponsored attacks, and these are the most capable hackers are state-sponsored hackers. They're basically professional hackers that are highly trained, and they develop a lot of stuff for their sorry, I'm getting distracted here. Hold on a second. Can you take that out in the other room? Thanks. Anyways, so the state-sponsored hackers can go really quickly. They can completely compromise a network in 18 minutes, and those are the most sophisticated hacks that are going to happen. And the other side is that a hack and a breach can go on for many months. The average is 8 months, but it can go for even longer. Some go undetected for over a year, 2 years. So if you look at the Yahoo data breach, that one went for over 2 years. So the moral of the story is that you need to be able to alert in real time, and you need to have a longer retention so that if something happens, you can figure out what happened and you can completely eradicate the hackers from your network. So what do you have to be able to do in order to do this? So the first thing you guys have to do is detect. So you have to collect event data. Event data comes in at a very high rate of speed. In some cases, if you look at a large telecom, they'll be collecting data at 1 million events per second. That's a lot of data. You need to be able to sort through this data, automatically identify with high fidelity which events are alerts, and then you need to be able to store all this data, be able to provide analytics on it, to be able to access it for threat hunting, visualizations, for forensics. And then you need to be able to have these alerts, respond to these alerts in real time. So, all of this has to happen quickly. You have to be able to store a lot of data, and you have to be able to analyze a lot of data. So it's a really great fit for a big data system. So what are the use cases that we're looking at here? So one way you can use the big data system with an existing SIEM or Splunk is to augment the platform. So basically you can take all of your events, you can handle all the high volume sources like Windows events, DNS events, noisy logs. You can basically pare down what you really need for feeding your alerts and for your dashboards for Splunk, cut out all the stuff that you don't need, and then send that curated data set into your SIM, because a lot of the legacy SIMs cannot handle that high events per second rate. And Splunk is quite expensive if you start just throwing stuff into it and you're not using it because you pay on ingest. So what we do is we take all of the data and we put it into an open data platform, and then we make that data available for collaboration across a number of organizations. So for example, cyber data is very related to other types of data like fraud. So if you start to look at a large institution, you're going to see that there'll be stovepipes, right? So the cybersecurity team is taking in a set of data, the fraud team is taking in another set of data, and some of the sets overlap, and as well as compliance. So instead of paying and storing and having to parse and understand all of the different data formats in different teams and forming these silos, we instead bring in all of the feeds to an efficient and consistent and correlated database. So that, big data systems, so that your cyber and your fraud and your compliance, when they have data sets that overlap, they're looking at the same exact view of that data. The other thing that's really helpful in terms of use cases is behavior analytics and advanced persistent threat hunting. So there are anomaly detection algorithms that you can use to create behavioral baselines, right? So you baseline a particular behavior, and then you look at an entity in comparison to other entities that are like it. So this is really important to figure out which entities belong to a particular peer group and which entities should be compared to each other. So for example, if you're looking at something like use of PowerShell in a Windows log, an endpoint device will start to light up and say, wow, PowerShell, PowerShell. But for a set of people who work in certain departments, like software developers, they use PowerShell all the time because it's just part of their development task. They're building something or they're doing some automation, DevOps. So that's a perfectly normal behavior. But if you start to look at somebody who is not a programmer, they start using PowerShell. Now it's something that's more likely to be an infection. So the good part about bringing all of your sources together is that you can take the anomalies that you're finding, and then you can correlate it with other anomalies in other sources, and then you can come up with a better high fidelity alert. So a lot of the sources that we're looking at in cybersecurity are point solutions, and they only have one view on the data. They don't really have a total view of all of the different aspects of the system. Okay, so let's take a look. This is the 50,000 foot view of the problem that we're trying to solve here. So on the left, we have a whole bunch of different log sources that are coming in. So some of them might just look like, just text, free-form text. Some of them might come in semi-structured in terms of like a JSON. This is a JSON event. And then some of them may be like a tab separated event. Okay, so we have these disparate sources. These are just a few examples. If you look at a larger organization, they're probably bringing in thousands of different formats. So we take these events, we have to understand the data that's in them. So obviously we can't just look at, just have these random pieces of text. They're not very useful to us. We have to be able to map the data that's inside of these texts into some sort of relevant structured data. And then we have to be able to figure out, okay, is this a benign event? Can I just store it away for future compliance and forensics? Or is this malicious and I have to start creating it or adding to it an existing incident, or do I need to actually go off and investigate it? And do I need to take some sort of action? So for example, if I have a hacker that's trying to take over an account, do I need to disable that account, or do I need to shut off a connection? So this is kind of the 50,000-foot view of what we're trying to solve. So this is the reference architecture. It's a very simplified reference architecture of what we're doing here. We have the raw logs that are coming in. They might need to be moved from wherever they lie, and then dropped into Kafka. So NiFi is a great way to pick up all the data that you need. So it handles a lot of different formats that you would use in cybersecurity, such as syslog, or a lot of data. If you wanted to be able to pick up files from servers, you could use a Minify agent on them, pick up the files, and then flow them into the data center NiFi. So NiFi is super useful for getting all of those logs and then dropping them into Kafka. And then we pick them up with Flink, which is a streaming analytics, complex streaming analytics system. It's a framework. So you need to build or use a log analytics hub on top of that. And then the log analytics hub is going to configure Flink to pick up all the events from Kafka, to do all of the different things that we need to do on them. And then we need to basically store them in the log event store. And that can be any number of different choices. So there are lots of different options that you have here in terms of Hive with LLAP, or you can use Impala, or in some cases you might want to pick up something like Druid, which is a time series database, which is really good at doing rollups and aggregate. So we're going to focus mostly on this aspect of the system, but just for you to understand the greater scope of what we're talking about. And then once you have them in the log analytics store, then you can start to do different types of use cases on them. So fraud and detection, UVA, threat hunting, response and investigation, reporting, and orchestration, the SOAR. In terms of building models, so we want to be able to build models on the data that we're collecting. So I'm going to show you some example of some profiles that I've built in the system, and then we want to be able to build machine learning that works off of the data that we're collecting, right? So we can build machine learning models, but they might not work because we're not collecting and calculating the features the same way in the pipeline. So what we want to do is we want to be able to build and train machine learning models right off of the data that we're collecting in our pipeline. We want to be able to build those models and then push them back into the streaming architecture so that we can then use those models to triage events as well. So I'm not going to show you too much about that today, but I'm definitely going to do that as a future meetup. So as I was telling you, the whole ingestion pipeline is very high throughput, right? So you're talking at least 100,000 events per second, maybe 1 million events per second. We want to do this reliably with exactly once ingestion. So we don't want to miss any events, because we could, what happens if we miss the event that actually has the breach in it? So we don't want to miss any event or lose any data. We want to do exactly once ingestion. And we want to be able to do counting and behavior analytics pretty easily. And we want it to be secure. So let's talk a little bit about how this works. So we have raw logs and they're coming in through NiFi. We are dropping them into Kafka, and we're putting some, so the the content of the message contains the actual raw text of the message. And then we put in a header what the source is. So we basically have one topic and all of the different formats are coming into that one topic. And then we decide what to do with it based on the header. So as we're talking about in the beginning, the events come in a bunch of different formats, and we don't want to be dealing with, random formats, unstructured text, etc. So we take these event formats, we parse them up, extract out the useful information, and then we put them into a common schema. And that schema is defined in the schema registry. Once we have the events parsed and normalized, then we want to add some information. So a lot of times we can't just look at an event as it comes through the system. We need some additional information in order to figure out whether to classify it as whether it's benign or whether it's malicious. So for example, some of the types of information we want to add are geolocation, user and asset information. So for example, anything that you know about the user, what department do they work in, assets, is this a critical asset? Is this some critical database server? Any threat intelligence that you have. So if you know about malicious domains or malicious IP addresses, and then any model predictions that you might have. So for example, I'm working with Ashrith Barther from H2O AI, and he has been preparing a generation DGA detection algorithm that we can then deploy in the pipeline here. So we pulled this out and we say, okay, what domain are we going to? And then we are basically going to send it into an event, a domain classifier to classify whether it's a generated domain. And then we can use that in our triaging. So some of the other types of interesting types of features that you might want to extract from the pipeline are profiles. So profiles are taking behavior and counting over time. So we take a bunch of different time periods, we're calculating and aggregating the data based on a particular key. So the examples that I'm going to show you are based on a host, but they could be based on a user or some application or subnet, some other type of key. So an example of using the profiles is detecting a botnet. So botnets are really, they're a really interesting topic of detection. So basically what happens is a bot master infects a network and then installs some malicious software onto a bunch of hosts. And the malicious software will call back to the bot master. And then the bot master can do what they want with that. They now have control of that computer and they can now use it to do other things that they want to be able to do. So for example, a DDoS attack. So the bot master can basically call up millions of computers and then start a DDoS attack or start phishing or start sending spam or doing click fraud or doing ransomware. And the idea here is that these computers are hard to block, right? So if the attacker was just attacking always from their own computers, then the networks could just block those computers, and then they wouldn't be able to do their attacks anymore. So the idea of this is they can always get fresh IPs and fresh hosts to do their bidding. So basically what happens is the command and control software will start to call out to these sorts of random domains, and it will start to have different types of fingerprints and different types of behavior based on whether the host is a botnet, is involved in a botnet or not. So this particular set of features comes from an academic paper. You can see the academic paper here. It's by Manmeet Singh. And it is doing anomaly detection on DNS requests. It identifies 15 different features based on profiling, counting DNS requests. And you can then take these features and then you can put them into a random forest model that will predict whether it's a bot or whether it's clean. So these are what, you don't have to understand exactly what these features are doing, but basically they're counting, right? So they're counting and counting distinct and then doing averages and maxes. So this is the number of requests per hour. This is the number of distinct requests per hour. This is the highest number of requests for a single domain per hour, average of requests per minute, and highest number of requests per minute. Now you'll notice that most everything I just talked about was per hour, but now I've got these averages over a minute. So I actually have to do aggregation over multiple time periods. So first I have to aggregate over minutes, and then I have to take all those minutes and put them into an hour window to do the average and to add everything up. And it's not just simple counting and averaging, it's cardinality, right? So for distinct requests of DNS per hour, I have to basically keep track of how many different domains I've seen in that particular hour period. Now, the implementation of this is a little bit tricky, because basically what happens is if you try to take the naive approach to this, so for example, counting distinct is not, there's no magic in that, right? You can just take a map and put or a set and put all the elements that you've seen so far, all the domains, into that set, and then that's you just do a count on it, right? So it's count distinct. However, when you're doing 1 million events per second, you need to have some more clever algorithms and data sketches in order to do that. So basically what we've done here is we've used the Flink tumbling windows. So there are a number of different ways to aggregate over time in Flink. So there's tumbling windows. And basically what this does is it cuts up each one of the events into minute long periods. And then it's going to call an aggregator for each one of those minutes. And then we're going to flow each one of those minute profiles into an hour tumbling window. And I'll show you what that looks like in Flink. So the moral of the story is, here's what their output looks like at the end of the pipeline. So we're basically calculating all of these features and then outputting them into the profile. And then what we would do is we would look at all of these measurements, and then we could run some, either put them into a model or do something else with them, and then make detections based on that. So this is the GitHub. We can send these out in the Meetup notes. But I'm just gonna walk you through how this works. So if we look at, so let's take a look at the events. So if we look at the raw messages that are coming in, we can go in, we can look in the Data Explorer. So this is a tool called Streams Messaging Manager. And it's basically, it allows you to do different things with your Kafka topics. One of the things that you can do is you can basically look around in your Kafka topics. You can also see, what topics do I have? You can create topics, you can manage them, you can look at your brokers. So it's super, super useful. I can't underscore that heavily enough. But yeah, so here's our topics that we have. We have the raw messages that are coming in. So again, this is taking in different different types of events. So these events that we see here are Squid events. So they are just, Squid is a proxy. It basically sits in the middle between the client and the browser and the outside world, right? So what this is doing is it's capturing all of the HTTP requests that are getting made through the browser. So it's really useful information because I can see what domains we're going to. I can see who's requesting what domains, whether or not they have things that are failing, what the size is, what the duration is. So it's a lot of really useful information here. See if we can see any more examples here. So the other thing that we have is we also have a protocol analyzer. It's called Zeke, and that is running some PCAPs. So we can start this up again. Where is my Zeke? Here it is. My connection is dead. All right, let's give that a minute to wake back up again. We'll go over and start looking at some Zeke. So basically, we're going to bring those in through the Flink application, and then it is going to write them to the enrichments topic. So we have the enrichments topic here. So we can look at some examples. You know, here's what they look like. Here's what the events look like when they come out of the, here's what the Squid events look like. Once that Zeke wakes up again, we'll look at some of those. But basically, you know, we still have the original string, which is right here. And then we've broken it up. This was implemented with a Grok parser. So Grok is basically an easier to use regular expression parser. So basically I can tell Grok to pull out all of the different fields from the string, and then I put it into this JSON object. And then we can see here that it's done, you know, it's pulled out some of the information about geocoding. So my destination IP, it's got the state and the city, and it should have the geocode. So it's got the latitude and the longitude. And so now, not only do I have a good idea of what countries and cities my clients are going to, but I also can tell if there's, you know, I can also like put them on a map so I can start to visualize them. So it's very useful information. All right, so some other things that we can do are putting the data out to AVRO. So I took the enriched events and I put them into AVRO. So AVRO is a schema. It's a schema, and it's a much more tighter data format. So if you look at the JSON, it's got a lot of extraneous information about it, right? So it's got all of the field names and all that. But when I look at these are the same enriched messages, but they're in AVRO format. And so as you can see, this is pretty tight, pretty small, nice compact format. Not so great to look at in the browser here, but if I go over here, I just discovered this today, so I'm all excited about it. So basically what this does is it will actually unpack the AVRO for you. And so I can see, here's my schema. managed in the schema registry. And then I can see here, it pulls out all of the AVRO fields. So I can see what the actual fields are in a little nicer format. So the AVRO here is something that would be useful for, so for example, I could pick them up in NiFi, I could put them into something like Hive, or I could, anywhere where I wanted to use a tightly defined schema, I could use that as well. Let's see. So just a couple of things to note. Error handling is a very important part of this pipeline. So for example, when I was building the AVRO serializer, I didn't really get I didn't get the schema correct the first time I created it. So for example, in this case, my port was coming in, I specified it was an int, and then my numbers were coming out as longs. And so I ended up with some errors. So basically what I set up here is an error topic. So basically any event that I can't go through the pipeline is going to come off into this error topic. And then I can monitor that error topic. You can do it with like NiFi, or if you wanted to push them into some sort of monitoring tool that you had, I can monitor those errors, and I can quickly, I can replay these events because I have the original string here. So I can just take the original string, and then I can push that back through the pipeline again. So that is super important, because what happens in cybersecurity pipelines is, you'll either get a message that's unexpected, or there'll be an upgrade that takes place and the message formats are no longer compatible with the version that you have. So that's error handling. If we want to take a look at some of the Flink, so I'm going to stop here. I've been going for a little while. I want to know if you want to take yourself off mute and ask a particular question, or if there's something else that you want to go over. What do you guys think?
You can also put your questions in chat if you don't want to speak.
Oh yeah, so if you're shy, you can put them in chat. I'll try to figure out how to look at my chat while I'm sharing. See if I can, there we go, chat, okay. So nobody has any questions. I'm super clear tonight. Either that, or you're all just like totally asleep and wanting dinner.
No, this is great. I'm just going over my notes, and all of this looks so good.
Cool. So I'm just going to finish up here by looking at just a couple of things about developing Flink applications. So if you look at what a Flink application is, so if you look at the Log Analytics Hub, GitHub, and you go down into main, you can go through the, I've separated out the Flinkness from the logic, the business logic of the pipeline, right? So one of the things you want to be able to do is in big data, it's kind of like the thing of the moment, right? I don't think, not that I'm saying Flink is going to go away because we just started supporting it, but we've gone through the retirement of Storm. So basically, I think it's a good idea that when you're developing your streaming apps, you take the streaming pipeline part of it and you separate it from what the actual application is doing. So that's what I did here. All of the stuff that has to do with Flink is in this pipeline package. if you look at, this is the multi-sensor. So I set up a couple of different pipelines here just to kind of fool around with them. But I have this multi-sensor pipeline, and programming Flink is basically, it's kind of like putting together pieces. You don't have to really write a ton of code, but you do have to, you know, it might take you 2 days to write the right 4 lines of Flink code. So if your goal in life is to write as many lines of code as possible, then maybe Flink is not the thing for you to do. But this is the pipeline that we have. And it's, as you can see, it's pretty, this is setting up the whole pipeline right here. You know, this is the whole kit and caboodle. There's a lot of, you know, there's a lot of business logic that goes on underneath it, but this is putting together the pipeline. So basically what we do is we take, it's a stream-based model. We're setting up a stream that then flows into another stream, and you can put them together and kind of paste them together in a data pipeline type programming. So the first thing we do is we're reading in the configuration properties. We're setting up the time characteristics. So you can either, let's see if we can make this a little bit bigger just so like your eyes don't start bugging out here. There we go. So what we're doing here is we're setting up the time characteristics. So there's different ways that you can deal with time. In Flink, you can either do the current time or you can do event time. So this will allow you to process data that has happened in the past. So for example, when I'm doing some of my data collection, I'm working on running that CTU 13 data set that has all my DNS calls in it through my pipeline. So I need to be able to operate in event time because the events happened in the past. And I did run a bunch of data through that, and then my profiles came out in the old just fine. But you know, using the old times, you know, the events that happened, I don't know, the event collection happened in like 2012 or something like that. So in terms of, you know, you can set the watermarks that says how long you're going to wait until you start to expel events from the system. So basically what we're doing is we're taking events, you take events from sources and then you manipulate them and then you send them to a sink. So this is a Kafka, this is our Kafka source. This is reading from the raw messages topic, and then it's parsing them, and then you're getting log events out, and then this is also a little bit more than parsing. So this is parsing, normalization, and enrichment that's happening in here, and then we're basically taking those events and then we're passing them into the this is a really long line. I should make this shorter, but basically we're taking, let's go back here and break this down. So we have the enriched events. We're assigning some timestamps and watermarks to it. So in order to set up windows, you have to be able to know what how to get the time out of the event. I'm just filtering out the types of events that I want to send to this window, right? Because I only want these DNS events to go through there. So I'm filtering those out and setting up the key. So the key is going to be my my source adder and my data set. So yeah, that's something I should probably just talk about. So in order to collect data sets and then in order to figure out, you know, like what events came from which data sets, so we can start running this. So I wrote a data generator. So I wanted to basically, I have these CTU 13 data sets and I want to run the DNS logs in those data sets through a data generator. And then I want to process them through my pipeline to get the profiles implemented. and collected and calculated the way that they would in my stream. And then I want to use that information to then train my models. But in order to train my models, I need to know where the data came from so they'll know how to label it. So basically what I did was I wrote this data generator, and it's a really super simple thing, right? It just reads the file and it just sends it to the producer. And then I have just a little bit of code here that will handle the time delays, right? Because we want the data to come out in the time that it was collected. So so basically I just read the file and then I replay each line according to the amount of time to wait between each message. So it's just a really simple loop that reads the file and then pushes the message text to Kafka. So that's that. So if I look at, if I go back over here, I can see that I have my log analytics hub, and for some unknown reason, it's not doing anything. That's strange. Well, it's because I didn't start replaying anything. Let's try that again. Okay, there we go. So now it should start doing something. There we go. Okay, so you can see it's running. I've got debug logging on here, so I can see it setting up all the profiles and processing the events. So when I start to see my events coming out of the enrichments, I should be able to see which data set they came from. So I go here, and I look at this guy, and this is really not so good looking. So let's pretty print it. One more time for the Gipper. Let's see. Nope. Too much. There it is. It's amazing how you can never find things when you're demoing. There we go. Okay, so this is my DNS event that I've replayed from that CTU13 data set. So you can see that here's the metadata down here. So I sent this in through the header in Kafka so that I can now trace where this event came from, so that when I start training my my machine learning models, I'll know which data set they came from, and then I'll know how to label it. Because I have to collect all this data, and then I have to label, you know, which IPs are which source IPs are malicious for a particular time period. So that's that. So you can see this is running. So this is one way I can run my Flink application. I can run it as part of in the debugger, but I can also run this in Flink itself on a cluster, which I will attempt to do. I changed things around a little bit today. I was working with this schema, so. Anyways, let's stop that, and we'll stop this. And while I'm getting this going, I will take any questions.
Carolyn, looks like we have a question from Chip. Basically, what percentage of cybersecurity analytics is completely unique and custom to the local environment, and what percentage is common? Chip, feel free to kind of unmute and elaborate on your question if you want to.
Yeah, this is Chip here. Hi.
Hi.
Yeah, I've done some of this type of work with the Elastic Stack, and I love it, and I think it's really awesome. But I was eating dinner while you were talking earlier, so I'm not sure. I didn't see a lot of the early dialogue or diagrams and so forth.
Could you speak up, Chip?
Yeah, can you hear me?
Yep.
Yeah, I can hear you.
Okay, so I guess my question is when you're designing these tools for cybersecurity using the analytics and Flink and everything, it seems like a high percentage of it is going to be very custom to the local environment, but my guess is there's probably a lot of stuff you can just inherit or pull it, some open source Flink processing of like certain logs and so forth that, you don't have to do it all, to create your environment, to create the dashboards and everything like that. So I guess when you're sitting down to design the security for processing the logs and is it mostly just totally custom stuff?
So this particular implementation is pretty custom, but it's extensible, right? So for example, the parser, the Grok parser. So Grok is a tool that's used in a bunch of different things, including Elastic, right? So for example, configuring each time you want to configure a new type of source, where is it? So if we look at log sources, this is the configuration for the Grok parser and the Grok, and for the Grok enrichments, right? So I basically have the Grok expression, and then I have to transform some of the fields into type conversions, right? So a lot of the stuff from Grok comes in as a string, got to make it into a long. So this is the timestamp field. I got to rename stuff, right? So some of the DNS features come out. Some of the stuff from the Zeke parser the Zeke protocol analyzer comes in and with the wrong field name, so you fix it. And then configuring the enrichment. So this is the geocode enrichment, so you can apply that. So this actually this is kind of a little bit hard coded here into the code, but you could as a next step, I'm gonna take this and write a config file so that all of this can be loaded from a text config file.
So is there some kind of place where people like collect these different recipes to say, if you're working with bind data for DNS, here's a recipe that will give you this. Or if you're working with RFC 814 data, you can work with this. Like, is there I don't want to say a marketplace?
Yeah, so there's definitely common data formats. So for example, if you're looking at the protocols, the proxies like Squid, or you're looking at Blue Coat, or you're looking at something that's coming from Zeke, or any of those common security tools, they're going to come in a common format. But then there's going to be a whole bunch of stuff that you're going to have to do for yourself, right? So you're going to have any authentication applications that you have inside of your own software. So for example, any apps that are custom to your particular organization, you're going to have to be able to analyze those logs and get the information out of them. So there's not going to be any, out of the box stuff that's going to help you. You're going to have to configure it yourself. But we have something that's not integrated into this is we have some parser. Like UIs that we've been working with that make it easier to develop, these types of expressions, Grok expressions, and handle, especially syslog. So syslog is a really difficult format because everything comes in through syslog. So you just have so many different patterns and so many different types of events. It's really pretty difficult to deal with. So when you start getting into syslog, then you can, you want to get more into a regular expression or Grok type parser. Any other questions?
I think we have one more from Kaito. I think it's more around for the log analytics hub. Are you using any additional tooling, frameworks, libraries? I guess that's the question, right?
Yeah.
Yeah.
So for this one, I use the MaxMind database, which is a database for doing geocoding. And then I'm also using in the profiler. So I was talking about how you needed to be able to use fast algorithms. So there's an Apache data sketches, which has really good fast algorithms. If you look at the profiling, where's profiling? So these are all of the profiles, kind of like the generic profiles that I defined for the system. So I was able to do all of the 15 different measurements that I needed in basically several different profilers. So count distinct, and then there were two types of count distinct. One was just a plain string. One was a string list. A count if, which is a predicate count or just a regular count. A max profile, and then a ratio and a top frequency. So, and then the groups are just aggregations of profiles. So being able to aggregate the minute long profiles into the hours. And then if you look at these, for example, doing count distinct, you have to be able to do this pretty fast. So my first implementation, my first cut at this, I just used a set, and I quickly just ran out of memory not too long after. So I ended up using this package here. Where is it? Apache data sketches, and this is the same data sketches that are used in a bunch of other database tools. So things like Druid and Hive are using the Apache data sketches. And so these are just aggregates. So I can basically take all of the minutes that I've collected, and then I can merge them together, and then I can bring those into get a final count distinct for the hour. So that's what these are what the profiles look like from the perspective of the implementation. So, you have to be able to add an event, and then you have to be able to merge two profiles together, and then you have to get the result. So when you want to implement a new profile, you just have to implement those three things. And then most of what the profiles do are actually getting delegated into these data sketches, these fast algorithms.
Cool, thank you.
You're welcome. All right, any other questions anybody has? Burning questions about other topics? Everybody just wants to go home and eat dinner?
I think they want to see more. So
they want to see more. Okay. All right, let's try to actually I have to copy one more file up here. So while I'm doing this, you can ask, I'm going to stop sharing. You can ask Amal, and I don't know, is Tim still here or did he drop off? Oh, Tim's still here.
Tim's
So
here.
you guys can ask. You can ask away some questions for Tim and Amal.
So I just want to loop back and make sure I followed everything because that seemed really interesting. So there was a point where, and correct me if I say anything wrong here, you set up a Flink job to read a data set in almost like the real time that it was recorded in, to feed that to a Kafka sync, then pick it up with another Flink job to do the processing, and then again feed it back to Kafka?
That's right. Yeah. So we dump the data into the raw messages topic, and then Flink picks it up, and then we do stuff to it, and then we put it into two different topics. Why does this not want to? Oh, okay. Because I'm not typing it right. It is getting late. Yeah, so I'm going to try and, so basically we've taken all the data, we've put it into raw messages, we picked it up, we parsed it, we normalized it, we enriched it, and then we dumped it out into the enrichments topic and then into the enrichment AVRO topic. So it's basically the same data in two different formats. And I did that because maybe Tim can answer my question. I had trouble getting rid of my dots in the so I had dots in the attributes or the field names in my JSON, and I wanted to dump that into AVRO, and AVRO does not like dots in its field names, and I was trying to figure out how to get rid of the dots. So Tim could probably answer my question. And
Knife-eye.
I know, knife-eye, but like I was just like, how do I do this? And I got into I got into some like groovy script that only worked with like 2 dots or something. And I was like, oh, okay, I'll just write it out.
I wrote a custom processor for that.
I know, yeah,
my AVRO cleaner.
The AVRO cleaner.
Yeah, that's a flaw with AVRO, is it's really picky on names. It's kind of a pain.
Yeah, it doesn't like having too many names here that have dots in them. So anyways, I wanted to drop my stuff into Hive, but then that will be a topic for a future meetup. Okay. All right, so let's go see if we can, I want to see if I can get this running. I committed the cardinal sin of demoing, and I changed my software on the day of the demo, and I added this config file. So now I have to copy this up to and I have to put it in my Flink config file. So anyways, this may be a super flop, but let's see if we can deploy this guy. And I will show you my knife-eye flows, which I forgot to show you. Let's see. No one really wants to see me type. All right, let's see. Tab, start Flink. Oh, my kitty even thinks it's intolerable. She's like, enough of this meetup stuff. Let's see. Okay, so temp, cluster prop, template. Okay, I just have to put my I'm sorry, kitty.
We're gonna have to do a cat-only meetup at some point.
Yes. Oh, I'm so sorry, kitty. Put the schema registry in there, but I did not put the other one. This may be an utter incomplete flop.
We really appreciate you being brave, though. Like, it's the like scariest thing in the world for so many of us. That like you being brave is very inspirational. So thank you.
Yeah, for real. +1 on that.
Yes, we'll
I
embarrass
agree.
ourselves in front of our peers here. All right, one other thing. I did show you it running in the debugger though, so I do get points for that, right?
Live in a debugger is cool.
Actually, it wasn't that easy to figure that out, but I did figure it out eventually. I mean, half the battle with this stuff is just kind of getting into it and getting, you know, getting started. And it's like sometimes you're like, okay, how do I do this? Just kind of like the basic stuff. It's like I just want to see my logs. Where's my logs?
What are your go-to resources? Like, how do you, like, when you say like I've got to go solve a tough problem, like you get past the Googling of it and look at Stack Exchange, like where do you go when you want to start doing some deep research?
Where do I go? Well, Tim can answer this one, but you know, at Cloudera, we have support, right? So that's obviously a great resource for getting help. You know, we have like tons of really smart Flink committers, right? So Cloudera is a great place. We have documentation, which is actually fairly decent nowadays. I'll have to say it's getting better. I would say open source software. It's, you know, the documentation is not always the best, but you know.
And then you always have the code as documentation.
And you always have the code. That's true. You can look at the code, which is, you know, you can't really discount that because I worked for so many years in proprietary software, right? And it's just like you just can't see what's going on, and I can't edit my file. All right, this is getting really boring. I'm so sorry.
Live coding is always rough, unless it's NiFi. That's why I love NiFi.
Yeah, I'm gonna if I don't get this going in about 2 more seconds, I'm going to show you my NiFi flows. I'm gonna pull a Tim span and show you my NiFi flows, which are nowhere near as interesting. Because I can see
Cat's like, no NiFi, no
really upset
NiFi.
over this. She does not want NiFi flows.
Yeah.
Right. All right, let's see. I'm gonna give this 2 more minutes. I've already said that about 5 times. All right. I have no idea if this is going to work. This is just part of the excitement of going to the live meetup. All right.
Don't worry, we'll fix it before. We'll fix it on YouTube.
We'll fix it on YouTube.
We'll
delete
edit it.
this. We'll delete this like pregnant.
We'll fix it in
pause
post.
here. We'll delete this pregnant pause from. The cat meows. All right. Okay. So what I am going to do here is just to show you. All right. So we have share screen. So I've got this start job. So basically, let's make this bigger. So Flink has a bunch of different interfaces that you can use for it. So I'm basically, I deploy this on AWS clusters that I tear down and I bring up, and I don't have anything really stored on them because we have this great like DIM team of yay DIM team that Tim is on, and they have this, basically I can like run a command, a one-line command, and it will completely bring up a whole cluster with all the stuff in it, right? So so this is good. This is good stuff, but it doesn't store anything, so I kind of have to reconstitute things as on the fly. So I basically wrote this automation that will build everything, push it up using SCP. It'll take a template and then it'll put in all the right host names, and then it starts the Flink job. So here's Flink, and it has a run command. It's got Flink and list. It's very similar to what Storm command line looked like, if you know that. It's running on a Yarn cluster. It's it's allocating the resources from Yarn, running on top of Yarn. It's my pipeline, it's the name of it, and then there's my jar. So I built, in order to run this on a cluster, you have to build a fat jar. And that's slightly tricky. You can look at my POM file to see how that works. And then I pass in the cluster properties. So here we go. Let's run this temp, start Flink. So this is going to go through, it's going to allocate some resources. It's going to go over to Yarn, and it's doing, if you've done any Hadoop programming, so basically it's submitting it to Yarn, and then we can see what happens. So we have to go over here. I'm going to go into Cloudera Manager. So this is the management tool that you use to manage all the services in the cluster. So let's take a look at this here. We have, this cluster has like a ton of stuff in it. I don't need all this stuff to run my example, but like I said, I've got all of this automation. It does all this stuff for me for free. So what the heck, right? So here we have Flink. So we can see, we can go over here to the dashboard, and then we'll see what happened. So you can see that I have 2 available slots, and I have 1 job that's running. So this is looking promising. So I can see that my my parser is running. Let's click onto this. Let's go to Task Manager. This is where you can see all the good stuff, right? So I can see my logs. Maybe if I'm good. Yeah, there we go. So I can look at my logs here. Okay, so this is looking somewhat promising. Now I'm gonna SSH in, and I'm gonna start my some of my DNS data going. I have like way too many, as you can tell, I have way too many of these open. Okay, so let's go over here. Let's not go over there. Let's go over here. So I have another host set up that I have Zeke protocol analyzer on, and then I can run some packets through it. So but I have to be root in order to do this. So let's run. So I'm running a tool called TCP replay. So I can see this is replaying a packet capture through a network tap, and then Zeke is picking it up, and it's going to open up the packets, and it's going to extract the information. So it's extracting the information about the DNS request, and then it's pushing it into the Kafka topic in a JSON format. So let's go over here. See if we can see anything going here. So you can see down at the bottom, I have all of my my pipelines. This is my pipeline here, so I can click into this. I would say there's not really much going on, so it's not. Does not have anything coming into my topic. Like I said, this could be a utter incomplete flop, but basically you can see something interesting here. So this is my Zeke. My Zeke is running, and you can see the, you can go in, you can look at all the detail for the subtasks, the task managers. You can click on the logs here. I can look at what happened in my logs. Doesn't look like I have anything coming in to my, oh, you know what, maybe I don't have messages coming into my topic. Let's look and see. We'll go over to Streams Messaging Manager, and we'll look at topics. And we're gonna look at raw messages. $723, I don't know. We've got DNS data coming in, but anyways. So something's not, I mucked something up in my code. feel not a good thing to do. Not a good thing to do. Oh, unless I still have this running. Let's just check and make sure I don't have something else reading my topic. Nope. All right, but anyways, you get the idea. This is your Flink. This is the dashboard. This is how you tell what's going on. You know, if we had events that were coming through the pipeline, we could see them. We could see them in here. You know, you'd see bytes received, bytes sent. You'd see parallelism. You'd see, you know, numbers. You'd see these numbers of records incrementing. All right. Any other questions? Oh, just so I don't look completely idiotic, let's look at my NiFi flows. And I have to plug myself into some power here so I don't run out of power. There we go. All right, so this is, I've got a couple of NiFi flows here, Squid to Kafka. So this is a very simple NiFi flow. It's reading the Squid logs. So I have a Squid proxy installed on this NiFi host, and it kicks off a var log squid access.log. So I'm basically tailing that file, and it's basically picking up all of the changes to that file that are occurring. And then I had to set the attributes in the header. So the way that I do that is I do this update attribute processor, and then inside of the configuration for this, I have the metadata. I have the properties that I want to stat. So this is the metadata.source and Squid. So this is how I add the properties into the header. And then if I go into the publish Kafka, I can see that you know, I've got the regular normal stuff that I would put in a publish Kafka. So I've got the broker URL, which, you know, I could use a variable here if I wanted to save this for and then, you know, push it up to the registry and then use it in different environments. I've got the topic name. There's a couple of interesting things that I did here. So in order to get the attributes to be pushed to the Kafka headers, I had to use this attributes to send as headers regex. So I used the dot star regular expression because I wanted to push all my attributes to headers. But I guess you could select whatever ones you wanted. And the other thing that I had to do was when the tail file tails the file, it gets a whole bunch of different messages together. Like, so it gets a big chunk of the file. So I basically have to cut cut each line in the file into a separate message that I send to Kafka. So then in order to do that, I had to put a return here, a new line, and there's a special super secret way to do that in NiFi. I guess it's not that super secret, but you have to do like a control or shift return. I think, is it shift return, Tim? I think it's
shift return, yeah.
Shift return,
it's a
yeah.
pain in the butt, yeah.
Yeah, so that's what's, so you can see there's a 1 and a 2 line number there. So there is actually a new line. And then I just started these guys up, and I pointed my browser proxy at it, and boom, I can collect Squid logs. So for example, we probably can see some of them. So if we can go in here, we can look at the provenance. We can look at this guy. We can look at the content, and we can see nah, I think my content got dropped. So maybe it's too old. Usually you can see the in the provenance, usually you can see the actual messages coming through. But we can also see that in I don't know, I think it's just too old. But anyways, so this is the NiFi flow. This is one example. You know, there's tons of, this is really useful in the cybersecurity context. And then also for dealing with the data afterwards, right? So I've got this Kafka to Hive, which doesn't entirely work right now, but you know, I can, in pretty much, if I had the right versions, my version of the schema registry that I have installed here doesn't work with the version of NiFi that I have, but basically, you know, I could consume these AVRO records and then convert them and put them into Hive streaming. So Tim's gonna take an action item to help me make that actually work. But we could do that. The other thing that we can do in NiFi, I don't have an example of it, but you can also use this to launch jobs after the pipeline, right? So if you wanted to say, whenever I get this kind of alert, I want to go out and get this information and I want to add it together and then push it to some sort of an incident management. You could do that with Hive. Just pick up the either the AVRO, you pick up the AVRO records for alerts, and then do your NiFi flows to, you know, call like a REST service or something to download some additional information that might help the analysts. All right, I'm gonna stop here because I've already talked a lot. So does anybody have any other questions before we wrap up?
I don't, but that was very cool. Thanks for showing us that.
Yeah, thanks, and thanks everybody for coming. I know it's the middle of summer, so everybody's everybody's got summer things to do, but I'm really glad everyone stopped by tonight and follow up with us. If you have any questions, be happy to answer them.
Thanks, Carolyn. Thanks, everyone.
Thanks.
Cool.
Have a great night or day, whatever time.
Wherever it is, wherever you are.
Wherever you are in the world.
Guess I'll kill the YouTube.
Have a good night.